Okay, hello all. Today we're going to continue on with trigonometry, and we're going to build on the work that we did yesterday, and I'm going to introduce to you the trigonometric ratios, or trigonometric formulas they might be known as, or trigonometric functions you might hear them, but most often trigonometric ratios. So the names of these trigonometric ratios, there are a lot of different trigonometric ratios, but there's three basic ones, and those are the only three that we'll use for junior cycle. You'll meet some other ones when you do the Leaving Cert. So the three trigonometric ratios are sine, cosine, and tangent. So that's the name of them, but you don't have to worry too much about those names because you rarely actually see the trigonometric ratios written using those names. Normally you see them written using shorthand, and the shorthand, which you might recognize because you might have seen it on your calculator for the last few years and wondered what they were for. The shorthand is SIN for sine, but we still pronounce it sine when we're saying it, sine. Cos, short for cosine, so sine, cos, and tan. Those are the three ratios, the names of the ratios that we'll normally use. So every time I refer to them from now on, I'll just call it, or I will write sine, cos, and tan rather than sine, cosine, and tangent. And you'll rarely hear a maths teacher referring to sine, cosine, and tangent. Well, sine, yes, because we pronounce this the same as that. So what are they? First of all, they are ratios which, they're like formulas which describe a relationship between the angles in a right angle triangle and the sides in a right angle triangle. Now, we won't be using them today really, so it'll become more clear how they're used and what they're for over the next few days. But for today, I just want to introduce them to you, to show you them, to show how maybe you form an equation with them without actually solving equations or doing any calculations. So that will come in the next few days. For now though, what we want to do when introducing these ratios is you need to be able to learn these off by heart because they're not in your log tables. There's a certain amount of information about sine, cos, and tan in your log tables, but the actual formulas themselves are not in the log tables. So here are the formulas, and then I'll go through a kind of a mnemonic that is often used around the world for remembering the formulas. So the first one is sine is equal to opposite over hypotenuse. So not the type of formula you're usually used to where it's just x squared plus 3 or something like that. Sine, and when we're writing it we leave out information here, but normally we put in an angle when we go to use the formula. So sine of some angle is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. Now, I know this must be terribly confusing so far for you because you have no context, but I'll show you in a second how we use them. So sine, cos, and tan, these are the formula that you need to learn off. All you need to be able to say is that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is equal to opposite over adjacent. And that'll be your first bit of homework, really. And our mnemonic we use for learning it off by heart, it might not seem like a great mnemonic to start with, but you will see this all over the internet in particular if you ever look up trigonometry in future. But it's this... SOHCAHTOA. So if you can remember this word and the spelling of this word, SOHCAHTOA, then you should be able to remember this. It stands for sine is opposite over hypotenuse, opposite over hypotenuse. Cos is adjacent over hypotenuse, A over H. And tan is opposite over adjacent, opposite over adjacent. So SOHCAHTOA, that's our mnemonic for learning the trigonometric ratios. So that's the first part of the lesson today. You'll need to learn them off. Now to see them in action, not really doing any calculations as such yet, but just to see what you'll have to be able to do with them for a start before you start doing actual calculations. Let's get an example. In triangle below. Find, let's say, sine theta. We often use theta for angles in right angle triangles, and in trigonometry generally, instead of using like the angle A or the angle B, we use the angle theta. So find sine theta, cos theta, and tan theta. Okay, so here's how we do it. We have to have a triangle first of all to work with. Okay, this is a right angle triangle. I'm going to say that this is 5. I'm not going to give it any units just to simplify things. That's 5. I'm going to say that this is 4 and this is 3 in length. And I'm going to have to make one of the angles here theta. So I'm going to say this one here is theta. Okay, so that's the question set up, and the question says find this, this, and this. So we have 3 things to do. Now, in all of our trigonometry questions, when you're given a right angle triangle, for now on, what you're going to do first is always label the sides in that triangle. So we know that opposite the right angle, which is this side here, that's the hypotenuse. And then opposite the angle that you're talking about, the one that's is the angle in the question. So this is the angle we're talking about in this question, is called the opposite. And beside the angle that you're talking about is known as the adjacent. So that's the first thing you're going to do for now on in all of these questions. And once you have done that, then you can get to using the ratios. So you must label before you can use any ratios. So the next thing we do, we know that sine is equal to opposite over hypotenuse. We're looking for sine of this theta here. Okay, so sine theta is equal to opposite. Well, if we're talking about what's opposite of theta, this side here, so we sub in a number instead of the word opposite, because eventually we will want to be doing calculations with these ratios or with these formulas, and so we need numbers to do these calculations. So sine theta is equal to 4 over, well, it's opposite over hypotenuse, so it's 4 over 5. That's the first part done. Sine theta is equal to that. That's your answer. The second part, cos theta is equal to, well, again, we have to look at what our formula says. It says the adjacent on top and the hypotenuse on the bottom. And this is why we call them trigonometric ratios as well, because ratios is like a fancy name for a fraction, isn't it? Because you'll end up with a fraction each time doing these. So adjacent is 3 and hypotenuse is 5. So it's 3 over 5. And lastly, then our tan of theta again is equal to, well, what does our ratio say? It's the opposite over the adjacent. So the opposite is 4 and the adjacent is 3. So it's going to be 4 over 3. Okay. Let's just look at one other thing then. If I had the exact same triangle and I put in another angle up here, let's call it zeta, we'll say. Okay, that angle there is zeta. And I asked you to find sine, cos, and tan of zeta this time. Well, first of all, what would I definitely have to do? And I think I mentioned this in the last video. Anytime you're using 2 different angles in a triangle and you're doing trigonometry, always draw out the triangle a second time and relabel the sides. Okay, so zeta is in there. That's the one we're dealing with this time. This is still same length because it's the same triangle, same length here, same length here. This is the side which is opposite the right angle, so that's still going to be the hypotenuse. But what's, oh, excuse me, I didn't have that in focus there. So everything is the same. That's the same length, that's the same length, that's the same length. This is still the hypotenuse because it's opposite the triangle. But what does change is now we're talking about this angle. And when we're talking about this angle, the opposite side is this one, the one which is length 3. And the adjacent side is this one, the one which is length 4. Okay, so if we were to get sine, cos, and tan of zeta, sine zeta, cos zeta, tan zeta, look what happens. So sine zeta is going to be, again, our ratio up here says it's opposite over hypotenuse. So the opposite is 3, the hypotenuse is 5, 3 over 5. Cos is going to be adjacent over hypotenuse, so 4 over 5. And tan is going to be the opposite over the adjacent, 3 over 4. But if we compare, and this is going to always happen in every right angle triangle, sine of this angle, 4 over 5, is the same as cos of the other angle, 4 over 5, 4 over 5. Cos of this angle is the same as sine of the angle zeta, 3 over 5, 3 over 5. And what happens with tan of each of those angles? Well, one is the reciprocal of the other. In other words, one is the other one put upside down, we'll say. So where this is 4 over 3, that's 3 over 4.